Hello everyone, my name is Remy. I'm part of the eth-docker crew. We're here today with Yorick, who's gonna do a nice little demo of eth-docker, but more to be more precise, we'll do a demo on how to set up a node using the Kiln network. So Kiln is this new testnet that's being launched for everyone to test the merge. So the merge is this next big protocol upgrade on Ethereum, and we want to make sure it works. So the best way to test that it works is just trying it, trying different clients, trying different setup, trying different configuration, and we'll do one today with Yorick. Yorick, tell us a little bit about what we're going to do today. What's the plan here?
All right. So we are going to use the eth-docker tooling to quickly spin up a node on the Kiln merged test network. If you are already staking, then this is really useful for you because right now you're running on mainnet, most likely, and you'll want to know what does this behave like with the merge, right? Kiln is your first opportunity to really see this in action and get familiar with how the clients behave together. It'll be very similar to what you're running today. And after that, we also expect Prata and Gurley, those two together, to be merged together. And then Sepolia to get a new proof of stake network and also be merged with itself. And those, hopefully, plans are still being finalized. Gurley and Sepolia will live after merge and will be the long-running testnets. Kiln should die with merge. So it's a network that we're using until the merge.
My
So
assumption on that was that Kiln was gonna be run even after the merge, maybe. I don't know.
I'm not sure. What I've heard right now, I mean, this is still being discussed, right? What I heard previously was Kiln is the merge network until the merge. Gurley will survive. Sepolia will survive. There's also discussions right now because of the craziness with bots on the Gurley faucets to kill Gurley and do a Gurley V2. We don't know, right? So, as with all things Ethereum, things change on a week-to-week basis.
Absolutely.
Yes, they do. Okay, so what do we need?
Let me go and share your screen here so that people can see what's going on. There you go.
Right. So we need a couple things to get going with this demo. We need a MetaMask installed with a throwaway account. I'll get to that in a minute. We need this kiln.themerge.dev site that gives us a bunch of links to click on from the Ethereum Foundation here. We need a eth-educators eth-docker GitHub here. And we're going to go to the merge branch
And for people
right there.
who are already asking, we'll share all those links in the description so
Yes,
that it's
yes,
easier for you
yes, we
guys to
shall.
access.
And then in the merge branch, you want to click on this kiln.md, or you can scroll all the way down and click on quick start. And those are the instructions we're going to follow, right? So let's take a look. Create a throwaway ETH address in MetaMask. I already did this. So here's my MetaMask, and over here I could say create account and create a throwaway account, right?
Yep.
Yes, you can do this from your main account, but come on, you're doing some testing, keep your main account safe, do a throwaway account.
And
And
private
then,
too.
yeah, definitely private, right? Fund this address with KilnEth using the faucet. So, or faucet, right? So if we click on this here and say open link, we'll get a little faucet, lovely little picture. Low supply, currently only available for ENS domains. So that's not going to work with a throwaway account. Plus, yes, there are supply issues. So I don't know what to say. We have a Discord where we have some other faucets available specific to Kiln. If you want to do this with something with an ENS domain, do that instead and ignore everything I just said about throwaway accounts. You need some Kiln eth. The eth-docker Discord will help with this,
Yeah.
right?
And
Yep.
we have general support as well. So if you have any issue, just come to the Testing the Merge channel on eth-docker's Discord, and we'll be able to help you guys with that. Anything you
Right.
have issue with.
And then prerequisites, you need a Linux or a macOS box to run this. By the way, shout out to the Besu team. They're the reason this runs on macOS. They tested that and it worked great. So what I'm going to do here is I'm going to show this on Linux. First, we need Docker because all this runs in Docker for automation purposes. So I'm just going to copy paste this. This thing already has Docker, but just so you see what this would look like. Yep, I have a sudo password. 1 second. Okay, so it just does its thing here. Then we need to clone this tool and get into the merge branch. So just copy paste all of this, and that will bring the eth-docker tool in, which is the wrapper around the official images, right? Like this. Yeah. I thought I removed it.
So this is a
Okay.
machine which was used before. So like,
Yeah, I've already used this for
if
testing.
you want to use a clean machine or a clean install of like Ubuntu or any Debian,
Then you won't have an issue. You can
yeah,
also run this alongside your mainnet node if you really want to. You'll just have to make sure the ports don't conflict, and I can show that here in a minute. It's
yeah.
not in the quick start, but I'll show it in this. Okay, we are getting there. Now configure this with eth-config. eth-docker has some wrapper scripts to make configuration easy. So we're going to use the Kiln merge testnet. If you don't see this, if you see Ethereum net, mainnet and Prata here, you're not in the merge branch, and start over, right? It needs to be the merge branch, not
Yeah.
the main branch. Our choices here are an Ethereum node, which has a validator client, and just an RPC node without a validator client. We will do this with a validator client.
The color scheme of this UI makes it hard for me to read it, but hopefully people on video will be able to see it
I
easier.
hope so too. Yeah, that's a good point. I don't actually know whether I can change the color scheme of what I'm using here, but I'll look into it. That's a really good feedback. Thank you. So we now need a consensus client and a execution client. The consensus client was previously also called the beacon client or the eth2 client, and the execution client was sometimes called the eth1 client. Remy, your choice. What should we choose as
Let's
our
go
consensus
with
client?
Nimbus.
Nimbus as the consensus client, okay. And then it asks me for graffiti. Anything you like. This is just for fun, up to 32 characters, right?
Yep.
And what execution client would you like to see?
Let's go with Aragon.
Let's go with Aragon. Perfect. Do we want to use Grafana dashboards? Why not?
Sure.
Okay, and then this is new, right? This is Kiln. What address do you want transaction rewards to be sent to? Remy, do you want to tell people what transaction rewards are? What is being sent here?
Yes. So with the merge, validator is gonna take the role of what miner used to do in terms of selecting transaction, including them into blocks, and proposing those blocks. And so they will be the one getting the rewards instead of the miner. And so in order to get the reward, they'll have to specify proper wallet address to receive the reward into. And so this is this configuration here. So make sure to select a wallet address that you control so you can get the tips from all those transactions.
Exactly. Yeah, if you want to be very nice, you can also send it to remy.eth, but no.
That's a
I'm
good
kidding.
that's a good suggestion there. Please do.
Right? No, I'm kidding. So these are the priority fees in particular that go directly to an ETH address and are immediately spendable and do not have to wait for withdrawals. Whereas even after merge, your rewards, your issuance rewards, which come from the chain itself, which is rewards for validation and rewards for creating blocks, those still go into the balance of your validator, and you'll need to wait for withdrawals before you can get at those. But this is the priority fee that does not come from the chain. It comes from the users. When you send a transaction on Ethereum through, say, a MetaMask, you say, or MetaMask says for you, this should be my priority fee. 2, 3 gwei, whatever per unit of gas goes to the miner. And this priority fee will go to validators. And that's where it goes, to this address. All right, good. So now this is done. It tells me that I have a compose file, Nimbus space, Eric and YAML, Grafana YAML, deposit CLI, that I have a rewards address here, and let's see what I need to do next. See whether my instructions are actually any good. Docker compose build. Okay, so I need to talk about this. Because these clients are in rapid flux on the Kiln network, we're actually going to do a source build. We're going to build this on your machine from source code. And it looks, it actually does this. No, it doesn't. Okay, great. I did that previously. I was hoping it would just use the cache. And it did, because otherwise we'd be here for half an hour. Awesome. So this will take a minute. Depending on the type of client, it can take between 10 minutes and an hour to build. Lighthouse, for example, takes a lot longer than other clients, right? Because it's Rust. So go do something else and then come back to it. I mean, you can stare at it if you like to, but for the most part, just walk the dog.
And I believe you can also use the eth tool to build your clients, right?
This is basically the eth tool. Yes, can be used, but it would be the same. It would be eth command build like this.
Something like that, yeah.
Let's do that again, and it goes through and builds it, right? So yes, you could. All right. So now we are going to create ourselves. So let me just look at this here. I am actually running here the deposit CLI.yaml. So I need to say about this, for testnet, this is fine. We're going to run the deposit CLI directly here, right? And the mnemonic, that means the mnemonic is on a machine that you actually is connected to the internet. This is not something you should do in production on mainnet. On mainnet, this should be a air-gapped machine where you run deposit CLI manually, and we can link to a video where I show what that looks like with, say, an Ubuntu, or you can do a Tails Live or anything like that. Don't run that. Basically, what I'm saying is in mainnet, stay air-gapped. On testnet, it's fine, because who cares, right? If the mnemonic gets...
And just so that people know a little more about this is mainly for security issues, right? You don't want anyone to be able to steal your mnemonic or your key stores, and you want those to be private. And so that's just a way to make it more secure. But since we're on a testnet, it's less important.
Right. Okay. And since we're demoing here, you will see the mnemonic, and we'll throw it away after and not worry about it.
Yeah.
Right. So now I'm running this command here, and you see I'm putting in a withdrawal address again. This is 100% optional. You can leave this entire eth1 withdrawal address out. I'll briefly talk about what it does. If it's here, then when withdrawals are enabled, they will only go to this address. So this should ideally be in mainnet something like a ledger, right? Or a Trezor, so a hardware wallet. This also means that anyone who has your mnemonic, including you, cannot change this withdrawal address. The worst they can do is get you slashed or initiate a withdrawal, but they cannot get at the funds themselves. They will always go to the withdrawal address. If you leave that out, then you would set the withdrawal address later.
Correct.
Okay. So this is the standard staking deposit CLI tool as it comes from the Ethereum Foundation.
And there's a few questions there you have to answer.
Right. So you're basically saying, first, what is my language that I want this to be shown in? Then second, what's my mnemonic language? There's only a few available here, right? So you see, for example, while this can be shown in Arabic here or in Greek, these are not available as mnemonic languages. And that's, because the word lists only exist in these options here. And then how many new validators do I want? In this case, one validator is 32 ETH. I want to run one. And we'll need a password for it. And this is just for the validator key store. If you ever lose this password, you can just run this again with deposit CLI existing and put the mnemonic in. Okay, I got that wrong. Let's try again. Man, if I could type. There we go. So write down your mnemonic. We're going to throw this one away, so I don't care. I'm not going to write it down. I'm just going to copy paste it. And it will create key stores for me. Lovely. All right. Next, deposit for this key at the launchpad. Do we want to show this? So become a validator. I'm going to next finish here. But for Mainnet, please do read all this. This is all important. If you get it wrong, you get slashed and
Absolutely,
you can't
yeah.
get out, etc. Tells you choose your execution clients. This will talk you through how to install those. You don't need to do that because we just installed them using eth-docker, right? So yes, I'm keeping all my keys safe, and I've written down my mnemonic phrase. Lies, I have not. And now I need to upload this file. So let's take a quick look. The generated files have been copied to .eth validator keys. Okay, cat meow. What? Cat dot eth validator keys. And here it is, key store. Nope, deposit data. I want the deposit data, not the key store. So I'm actually just going to take this and stick that into a file on my desktop so I can load it.
Easier than just copying the file for you, I guess.
Yeah, I could just copy the file as well. Right now, it's for this test here, it's super easy to just make a file, right? But yes, I could also just copy this file. So deposit JSON. If I were to copy it, however I want to get it off my Linux box, I can use like a WinSCP or any kind of SCP, which is a secure copy. I can use, if it's a physical machine I have nearby, I can use like a USB stick, anything I like, right? Nothing in deposit.json is in any way security conscious. It's all public data that will end up on the blockchain. Continue. And we're going to use MetaMask here. And it tells me I have enough testnet ETH and continue. And now again, I have dire warnings that if I get this wrong and show my mnemonic just like I just did, I'm screwed. And send this deposit. In this particular case, I will actually not confirm because we're going to throw this away, but that's what you would do. You would click confirm here, right? And then it will deposit into the deposit contract for you, and that thing is ready to go. So I'm going to reject the deposit. Okay. Now we need to take this key and import it into our client. So we'll do an SD key import. And I need the password that I had given for the key store earlier.
And if you don't remember the password, you can always recreate the key store.
Yep.
But it should be the password that you entered during the.
I love it. I actually managed to fat finger my password and I don't know what it is anymore.
Yeah.
So, not a problem. We still have in the scroll back my mnemonic. So now we're gonna recreate this thing.
We'll be able to show the other path actually, the path
Yeah,
where you forget the password.
right. Nice. I love it. Okay, this is great. Okay, So now we're going to do deposit CLI existing, put the mnemonic in again. My index here is 0, so from the beginning, 0. One validator, and try again with the password. Okay, now in this case, because I have one that I just forgot the password for, I will need to remove this, right? The old one. Key store 2. That one is the old one. Let's try this again with import.
Third time's the charm.
Okay, good. I knew this time I had the right password. So now the key store is imported. And now the only thing we need to do is start the stack. Okay. And then I can look at the logs of this stuff. So let's take a look at the execution client, which I think was Aragon here. Actually, in the case of Aragon, it's f-aragon. And I see this thing running. I did have this synchronized earlier, just so that we can see this running. But typically, what would happen here now is it would start synchronizing the chain. And then the same for consensus. Actually, that one might not be synchronized yet. Okay, so this is complaining right now that it can't get Aragon. And the question is why? Yay, testnets.
That's one of the reasons why we run them. We want to see if our tools works.
Right. Yes. I'm actually not entirely sure, but what I'm going to do is I might have confused these things by having them previously synchronized differently, and now they're like, I don't know what's going on. So we're going to start over. We're going to prune everything. I'm going to import the keys one more time. And then we're going to see what happens if we restart it. If this genuinely doesn't work between Nimbus and Aragon, that would be a good result as well.
Because we could report it to the teams eventually, and maybe there's a bug in some of these.
Yep. Yeah, this is weird. I would expect it to try and synchronize the chain. There we go. Okay, so it is starting this now. Number equals 0. Okay, it needs to find peers. And this thing is unhappy, obviously, because it can't find the deposit contract block, which is fine because the Aragon isn't synchronized. So this isn't going to do anything until that thing is synchronized.
And from here, this is mostly a waiting game.
This is now a waiting game, and we're not going to wait for it. But now you wait for this to be active, and then you can look at beacon chain kiln the merge.dev here to look up your validator. So in this particular case, let's see whether it showed me the validator. Does not cat.eth.
So
validator keys. Now I actually didn't deposit for this, so you're not going to find the thing in this particular case, right? But you would take the public key, here it is, and stick this in here and say, go find this for me. It's not going to find it because we didn't deposit for it, but that's essentially it.
And
Okay,
on the beacon chain explorer, you can also find your deposit using the wallet address you deposited from.
correct. Yes, you could do that. In fact, if I do that, I should actually find a deposit for one that I did deposit for. There we are. So this validator key here, currently not active because I shut down my test, right? You can see here I'm missing attestations when we started recording. And I shut down my test and we did this instead. So that is findable through the address from that we deposited from. Yeah, I think that's it for the demo, man.